Hello, today I will be talking about my machine learning project, which was using the Parkinson's telemarketing data set to uh, do a regression model. So about this data set, the data set uses acoustic features to estimate the clinical rated total unified Parkinson's disease rating scale, or UPDRS. And it had features that were categorized as numerical or categorical. So most of the um, feature types were numerical, such as the jitters and the shimmers. The only feature that was categorical was the sex, where the males were classified as 0 and females as 1. For the feature engineering, there were three total columns that were removed. The motor UPDRS was removed due to the fact that it was very close to total UPDRS, and so the model was not actually performing the. It would create data leakages. The subject number was also removed because it was basically the ID, which again created data leakage. The last one that was removed was age, due to the fact that Parkinson's is, you know, associated with age, so is dependent on age. So as a person grows and ages, their um, data that was given in this set would also be worse than that of a younger person. And so the model wasn't actually learning anything new or predicting it according to that. It was actually just basing it on age. So when I originally performed it with age, age as part of the data set that I was using for the testing and the training of the model, but I was getting a R squared value of 0.99% or 0.99, which was indicating that something was off. Um, as you can see, the best model that was used for this project was the extra trees regressor. As you can see, the values of MSE, the mean squared error, and the root mean squared error, as well as R2, R squared, was the best for extra trees regressor as the model. So that is the model that I chose for the this data set. Um, Here, you can see the metrics that were used, and the metric that was used was the mean squared error, as well as the root mean squared error and the R squared value. Here, you can see the residual plot for the extra trees regressor, which was the best model. Each point is one prediction. The x-axis is the predicted UPDRS score, and the y-axis is the error, which is the residual. Uh, as you can see, most points are clustered around the 0, which means that the model's prediction is generally close to the true values, although there is still some spread, especially with the higher scores. And that is how it resulted with a test R squared of 0.46. So the model captures a moderate amount of the variance, but there's still room for improvement. Here you can see the predicted versus the actual UPDRS scores for the extra trees model, but this is specifically the prediction error for this model. The dashed line is the ideal or the perfect prediction line, where the prediction equal is like exactly what we're wanting it to be. And the more solid line, like the more darker solid line, is the line of best fit for my model. As you can see, the points roughly follow an upward trend, confirming the higher scores tend to get higher predicted scores, but there's still noticeable scatter, which reflect to what was shown in the previous slide where the R squared is 0.45. I took here, you can see the prediction label. So each row is a subject with some of their acoustic features. And the last column is what the model's predicted UPDR, total UPDRS score is. And this shows how the model takes the voice features and outputs a concrete clinical score that could be monitored over time in the telemonitoring setting. And lastly, I have the pipeline. So this is the machine learning pipeline that I used. So first, the values in the numerical, the missing values in the numerical and categorical features are inputted, and then the column names were cleaned. And the processed data was then passed on to the extra trees regressor. Uh, Packaging everything into the single pipeline helps ensure that the pre-processing and the modeling are applied consistently during both training and prediction, which is important in this data set of the telemonitoring system. Yeah, thank you.